Hey guys, welcome. Yeah, so in this video, I'm going to introduce the Weirstrass substitution for integrals. And as this is example 0 on the Weirstrass substitution, we're going to talk big picture and see why and how it works. But at the end of this video, I'm going to give you a practical example. In other words, I'm going to show you how to apply the Weirstrass substitution at the end of this video on the integral this here. Now, in a video series called Important Integrals, I already show you a couple of different methods for doing this integral of secant theta d theta. But of course, as I said, at the tail end of this video, we're going to see how to do this integral using the Weirstrass substitution. And this actually is a good segue, which is talking about this integral in the context of the Weirstrass substitution, is a good segue to talk about what the Weirstrass substitution is good for. So, the Weirstrass substitution is useful on integrals that are quotients of trigonometric functions. So in addition to doing this integral at the end of example 0, we will in subsequent examples work on this and another integral that we will do using the Weirstrass substitution as this one. And what they all have in common, as I said, is that they're all integrals that are quotients of trigonometric functions. That's when you want to use the Weirstrass substitution. And the Weirstrass substitution, regardless of what integral you're working on, always starts the same way, which is it starts by making u equal to tan of x over 2. Obviously, you can use a different letter than u and a different letter than x, but it always starts with this substitution. That's what the Weirstrass substitution is. So then du is going to equal secant squared x over 2, and then by chain rule times a half, and then times dx, right? And then we recall from trigonometry that 1 plus tan squared theta is equal to secant squared theta. We know this from trigonometry. So when theta is x over 2, we see that 1 plus tan squared x over 2 has to equal secant squared x over 2. Okay, but then x over 2 in the Weirstrass substitution is u, so that means 1 plus u squared is equal to secant squared x over 2. So that means I can change this secant squared x over 2 with 1 plus u squared. Got it. Okay, and I don't need this anymore. So there's that. And then, of course, here, I want to solve for dx. So we're going to write 2 du divided by 1 plus u squared is equal to dx. So again, as I said, because the Weirstrass substitution always starts with this, dx will always be this. So example 0 here is the most important example, because in this example we're going to come up with what dx has to equal using this substitution, and as you'll see shortly, we're also going to figure out what sine has to be based on this substitution, what cosine has to be. So basically, you shouldn't reinvent the wheel and always start your Weirstrass substitution by writing this. You should instead see what we figure out in this video and then pick the things that you need, right? Like for example, when you need dx, you know that it's going to be this because this is how you would start that integral, yeah? Okay, so let's box 2 du over 1 plus u squared is dx, or let's put it in a bubble since I can't box it now, because we're going to need that in a second. And as I said, of course, this comes from this here, right? Okay, but otherwise let me erase, and as I said, let's figure out what sine and cosine and so on have to be based on this substitution. Now, notice that a u equaling tan of x over 2 amounts to saying that in a right triangle where the acute angle is x over 2, tan is u. Tan of x over 2, that is u, which is u over 1 if we want to see it as a quotient, meaning the opposite side is u and the adjacent side is 1. So then the hypotenuse has to be the square root of 1 plus u squared, right? So the hypotenuse has to be the square root of 1 plus u squared. Got it. So based on this then, we see that sine x, right? Sine x will have to equal, 2 sine x over 2 cosine x over 2. This is just using the sine double angle formula. So that means that sine x is equal to 2 times, well, sine of x over 2 based on this visual is opposite over hypotenuse. So that's u over root 1 plus u squared. That's sine of x over 2. And then cosine of x over 2 is adjacent over hypotenuse, so that's 1 divided by root 1 plus u squared. Right? Okay, so that means that sine x is equal to 2u over 1 plus u squared. So that's sine x. Got it. So let's write that somewhere because we might want to use that also. So sine x, well, you should definitely write it down if you have homeworks on the Weirstrass substitution, because yeah, it'll be handy. But yeah, this is sine x. Yeah? Okay, cool. And then cosine x, using the cosine double angle formula, in particular the cosine double angle formula that says that cosine 2 theta is equal to cosine squared theta minus sine squared theta, right? This one of 3 versions of the cosine double angle formula is what's useful in the context of what we're discussing. So yeah, like, so then we see that cosine x is equal to cosine x over 2 squared minus sine x over 2 squared, right? Okay, so cosine x is going to be, well, cosine x over 2 is 1 over root 1 plus u squared, but then we have cosine x over 2 squared minus sine of x over 2 is u over root 1 plus u squared, and if, well, it's sine x over 2 squared. And so if you, like, you know, square this and square that and take the difference, what you'll find is that I don't need this visual anymore, but I need the space. But yeah, what you'll find is that cosine x is equal to 1 minus u squared divided by 1 plus u squared. Alright, cool. Now, if you have sine and cosine, then you can get to all the other trig functions. In particular, you can get to the other 4 trig functions. For example, when you want tangent, you do sine divided by cosine. So tangent ends up being 2u divided by 1 minus u squared. And then when you want cotan, you take the reciprocal of tangent, right? So cotan is going to be 1 minus u squared divided by 2u. And if you want secant, then you do the reciprocal of this. And if you want cosecant, then you do the reciprocal of that, right? So basically, this is all you need for the Weirstrass substitution, is what I'm saying. What I've done so far is all you need. Yeah? So as per promise, let's do the integral that we said we're going to do at the end of this video, which is sec theta d theta using the Weirstrass substitution. Okay, from what I just said, and let's, you know, theta or x doesn't matter, so let's use x here. Easier on the eye. But yeah, from the substitutions that we just discussed, we know that secant is going to be the reciprocal of cosine. So we see that to start, and this is why it's so useful to not reinvent the wheel and to, like, make use of the things that we worked so hard to, like, come up with, right? So anyway, 1 plus u squared over 1 minus u squared is what we'd have to start, right? Okay, that's what I just wrote down is sec x. Based on the substitution, u equals tan x over 2, right? And then dx, we've conveniently put in a bubble, so I'll put the 2 from the dx right here. But the rest of it is going to be 1 over 1 plus u squared du. So I'll just write that. Oh, look here. Boom, boom. So the integral that you have to do, and I'm actually, for reasons you'll see, going to put the 2 back in, but it's going to be 1 minus u squared du. So this is what we'd have to do. All right? Okay, cool. I'm kind of running out of space, but yeah. Okay, so 2 over, let's write it right here, 1 minus u squared du, right? Okay. And clearly, what we have left to do, remember we're working on the integral of sec x dx. But yeah, what we have left to do is some partial fraction decomposition, right? So we go 2 over 1 minus u squared is a over 1 minus u plus b over 1 plus u, right? And right? Okay, so 2 equals a times 1 plus u plus b times 1 minus u. The partial fraction decomposition you should know how to do. But yeah, if I let u equal 1, I get 2 is equal to 2a, so a is equal to 1. Okay, and then if I let u equal negative 1, I get 0 plus b times 2, right, is equal to 2, so b is 1. So a is 1 and b is 1 is what we'd find if we do partial frac decomposition. So that's nice. Alright, so what we do is erase what I wrote and replace the a and the b with a 1 and a 1. So 1 there and 1 there. So this integral du is the same as this integral du. And it turns out that this will have to be the natural log of 1 plus u minus the natural log of 1 minus u. Now, be careful. Yes, when you do the integral of this, that's what's turned into negative natural log of 1 minus u. This negative comes from like that minus right there, like when you do the antiderivative of this guy. So you should know, but like ask questions if you're unsure about how I got this. But basically now we're saying that from here, we have the natural log of, using the log quotient rule, we can write 1 plus u divided by 1 minus u, right? Okay, okay, so we're ready to say that we have solved this integral other than our plus c, just recalling that u is equal to tan of x over 2. So if I put tan of x over 2 in place of this u and this u, I am done with the Weirstrass substitution. But wait, I said that I already showed you how to do the integral of sec x in 2 different ways in my video series on important integrals. And this answer, if we substitute for u with tan x over 2, it doesn't match those 2 answers. And so here's what we can do to make it match, which is, well, if we take 1 plus u over 1 minus u and multiply both top and bottom by 1 plus u, then what we're going to get is this here, which is we're going to get the natural log of 1 plus 2u plus u squared, and then o over 1 minus u squared it's going to be, right? Okay, cool. And then from where we're at right here, like let me take an arrow, we could write the natural log of sorry, I'm writing sloppy now. The natural log of, and it's going to be 1 plus u squared over 1 minus u squared, and then plus 2u over 1 minus u squared. But wait, this here, 1 minus u squared divided by 1 plus u squared, is cos x. So this must be the reciprocal of it. This here must be sec x. So this here is sec x. And if you take sine x and divide it by cosine x, then we said you get 2u divided by 1 minus u squared. So that's right here. That must be tan x right here. And now we is satisfied because this answer matches the 2 other ways that led us to this answer when we did this integral in my video series on important integrals. Yeah? Okay, cool. Otherwise, I hope you enjoyed this. As I said, more examples to come, and keep watching. Take care.